For this clip, we will talk about exponential functions, logarithmic functions, and logarithmic properties, just as like an introduction to what they are. So the functional form for any type of exponential function is something like this, where you have a coefficient. You can have a coefficient, but basically you need to have some sort of number raised to the x power. So instead of typically having x raised to a power, an exponential function is having a number raised to the x power. So something like this would be a exponential function, or something like this would also be an exponential function. That, and we also have a mathematical term called an exponent. It's called e, which is also an exponential function. It's for a natural logarithm, which looks something like this. This is still an exponential in the same type of mindset, because e is just a specific mathematical constant, which actually has like a number associated with it, kind of like pi. So in this case, yeah, again, it's just a number raised to x, making it an exponential power or exponential function. Logarithmic functions are also very important and semi-related. The logarithmic function is of the form of something like this. You have b here, which is like your base for your log function. X is nested inside the function, so it's technically a nested function. And then you have this equaling some value, as they do. In math, we like to use natural logs, I think, more often than traditional logarithms. Natural logs are just logarithms in base e, whereas like other logs are in base 2 or in base 10. Those are both pretty common. Natural logarithms, again, are in base e. To do a change of base is simply to do something like this, where if I want to go from log b of x to log b of a, then I want to divide log b of x by log b of a. So you basically divide your original by the same based logarithm, but the base that you want it in, you put that inside your nested function. So logarithmic properties that are worth memorizing, because this is the type of like algebraic practice that you will be doing, is the product, quotient, and power property. Logarithms are a little weird, where if you have two logarithms of the same base adding together, so if I have like log base a of like 2 plus log base a of like 3, then I could actually combine these into one log, having them log base a of 2 times 3, so it would be log base a of 6. The product property just tells you that whenever you have two logarithms adding together, you can turn it into one logarithm with the inside nested formula, like x and y multiplying together. So you could probably guess similarly, the quotient property, unlike the product property, is going to be like, instead of adding them together, if you have two logarithms of the same base subtracting together, instead of multiplying the inside components, you're going to divide the inside components. So if I have log x minus log y, then that can be written as log of x divided by y. So just even knowing one of these, you can pretty much like induce the other one. So this kind of comes a little bit more easily. The harder property to remember, I think, is like the power property, because sometimes these exponents are not as easy to see. The power property just tells you that if you have the nested function has a power attached to it, like log of x to the n, then that means that you could write that as n times log of x. The reason I say that this can become a little bit more tricky is because sometimes you'll have inside functions that don't necessarily have exponents, but can be written in a way that they do have exponents. So like if the inside function was like, let's let's say this was like log of 1 over x plus 5. This could be written also as log of x plus 5 to the -1, right? Because this anything raised to the -1 can just be is just putting it under itself as a fraction. So if I write it like that, then this could also be written as -1 log of x plus 5. So a little less easy to see, but the power property becomes also quite useful when you're trying to simplify logarithms down to smaller and simpler terms.